Hi everyone, how's everyone doing? I'm just gonna confirm real quick that we are live. Okay, looks like it. Let's give ourselves a like. Um, yep. Welcome everyone. If you're just joining, I will be continuing with work yesterday. I've been trying to get a little bit more rest lately, and I think that's a good thing because um, I had not been resting properly, but now I've been paying a little bit more attention. But actually, that's also been due to a consequence of me not using my supplement, which has kind of made me a bit tired last couple of weeks. But it's all good. Welcome if you're just joining, and I appreciate everyone that joined the last stream. It means a lot. Hope everyone is doing great today, though. I'm just picking up things right now, so let's see where we were yesterday. Art direction. So for updating, we've got struct, origin struct, identifier. We've got field type. We've got create name, of course. We've got the edge type, relation, attributes, just relation. Okay. Release attributes. Okay. Then actually, I think this should probably have just come from, well, sorry, relate here. Edge table name, that comes from that. Not table name. And there should be three things actually from this: edge direction, edge table name, not table name. Okay, we'll go edge direction here. Perhaps we should take this up a little bit. So if we want to make it, we could actually do relate attribute. Right. About we do something like that. So we get this tree right off this direction. Let's take a reference to that. Okay. Destination, no table name string. I don't think we actually need that. Let's check. We're using it with destination, no table name string. Table. That would be cookie different. Let's see. Not table name. Just string. Yep. That should give us what we want. Alternatively, we might be able to actually do like field type. Also, let's just do definite. To have the definition, no table name, and I think okay, we want that as string actually. Not table name, but how about we implement that as the tokens, right? than implementing that as an ident, we implement that as a string actually. So what do we implement for this? What about the not table name rather than that? Actually the create token something like that. And not to create custom temperature resources. Let's just leave as is. But I think we shouldn't have it as an ident by default because it doesn't provide us much utility if we do so. Since we really truly don't want that as an ident, I don't know what context we're using that as an ident. So taking that to a token is not necessarily, but let's have that string here first. We can always do something different later. Then edge table name as method. Okay, how's that being used here? Let's take that. Couldn't I have just taken a reference to that? Why am I using it as a closure? Edge name as ident. Okay, fair enough. Let's go up a little bit. So we've got the generics from the edge type, and we've got the destination schema ident pascalized table name tables. Why don't I just do something like this? Send that to this and take that. Destination table name and now we have this string, then pascalize that also. We could have actually just, we could do something like this also. That would be field type name. We certainly can use these since this would be Pascal format, but the type identifier isn't as interesting as the table name itself, because the table name would be consistent. It has to be the stable name. It's gonna be stable, but the type, you can imagine a situation where a user uses a type alias. So in that case, I would maybe gravitate towards using the table name itself because it's more stable. Represent the schema, but alias. Blah, blah, blah. Yep. So what else do we need here? Destination node, schema type alias. Basically taking the no schema ident and giving it some generics. We certainly can parse this style there. Something like this should be kind of interesting there. I'll leave it at that first. Now for each direction we can actually just implement the string, but yeah, certainly we can have the method here. Let's say maybe I think that's contextual enough to actually implement it there. It's very context specific. So we get the in and out. So we get destination type areas. Oh, I see. That is not. I wouldn't want to rename audio currencies destination type is. Just to kind of like give it that. See, we're not using the type. Probably. That's fine. We can have it as a token stream. It's fine. Because even if we have it as a type, so basically we get a hedge and we get the whatever node depending on the direction, if it's outgoing or incoming, and we get the destination or the foreign node from this, and from the foreign node we can also get a schema of that using the trade schema getter. So this is a little bit of Rust gymnastic, but if you're familiar with trade associated type, and this is a way you can do some migration and stuff. But yeah, we get that. I believe this is one of those places where I messed things up. I actually want this in foreign node connection method. H destination node. Okay, so I can actually do let's go edge to destination method. And connection. Yeah, I think this is actually better descriptive. Let's wrap that. Just to give it a little bit of edge to destination method. Then what is this? Destination node schema. We see destination node schema. Destination node schema. Yes, that's good. So we get a better description of what we're doing, and you just kind of even this, I would like to call this something a little bit better descriptive, and I'm calling it foreign node in out. It's okay since we're using it, but it's like I don't know. Foreign node affected typing but this time around we're actually create identifier and yep, the benefit of that is, when you hover that, you get better description, and honestly, this is probably fine. It's fine. Probably we might be able to put some of this in some helper method, but I'm actually thinking, is it even better that we are inlining everything so you're seeing the logic, the flow of the logic directly? But I guess I will do this first pass. After doing the first pass, then I'll see if we want to abstract things. Search to destination, so like destination node table returns the type alias that comes with the generics already, and so does it here. And I guess they're gonna be inheriting from, they're gonna be using the generics, trade bounds, and the lifetime the lifetime bounds from the implementation block, so we don't have to put the the bounds here or the where clause or whatever. Well, you can have the bounds here, or you can have the where clause here, but we don't need that since they will be taking that from the struct, and since the edge is like the super, you can think of the edge struct as the super struct of the destination and origin. It means every generics, both lifetime generics and the normal generics, because lifetime are basically generics at the end of the day. Any generic that is used in origin and destination node would exist for the bridge table, the edge, because the edge is what connects the origin and destination, right? So we'll take that. We have that. That's good. Connect. So yeah, that's good. saying create static assertion. What are we doing with the static assertion? We're probably passing it to the node add meta and let's so what we do with the static assertion. Okay, node edge meta. So we're doing this creating static assertion, but good. Let's close this. Pressure. In the static assertion here, what if we go to say node is node edge meta. Okay, generate static assertion. Static assertion. So in that case, we can just put it directly in there. So we're doing like generate. I think what we should do is, rather than having this generate token string, we're just gonna implement 2 tokens for node edge meta. Then we're gonna have a method, separate method on the struct that's gonna return the static assertion. I'll just take care of that during creation anyways. Just close everything first. So yeah, what if, so basically we are passing self, in this case node edge meta store, but what if we actually do pass in this store directly, and for that we pass in the fields meta, because from the fields meta, right, we can get store dot node. Okay, this should be on this other side. So let's see, from this we can do store dot node edge meta. Probably should fix that. Let's go metadata. We're gonna have that. Pass that in there. So since we're gonna have this anyway, we could, let's see what how we're generating. First, let's say we're using store. We're not really using this here. We're doing self. Dot push. Self dot add direction. Create static assertion. Entry. Okay, so probably having a self there wasn't helping us much anyways. This could as well just be an associated function, probably should be. So yeah, we might be able to do self do that. It's kind of like indication to ident rather than saying ident. Why don't you say edge ident, or actually just take the edge table name. Edge table name. Yeah. And edge direction. I believe this implements to display. Right, here we go. Yep, it should. Let's check this. It doesn't implement display, but it does implement the ref to ident, which implements the string. So I mean, we could come back to that. That's just to be sure we can do htable name to string since it implements the ref. Anyway, so we have this as store, or what else we kind of call that. We scroll down a little bit. Well, how we using self? We need to relation activity. Okay, that's weird. Relations attribute. Okay, because I'm not destructuring it, we can get this directly. I don't think we need to do this cloning anymore since we're taking reference. We're referencing all these things, and this should be a reference. And maybe we could just do this. So that gives us the edge table name. We might actually be able to improve all this. This gives us the edge table name. And what else do we have here? So we have the edge table name, which comes from the edge table name. That's actually what we want. And the direction, we've got that. Destination nodes schema. Basically, we're able to retrieve that via the edge. We check the destination node, which could be in or out. Then we check the schema of the destination node by using the fully qualified path to getting an associated type, which basically you use as the traits, then you access whatever the associated type is. So we're able to get the destination node schema via that means. Let's see. Okay, that's great. So this actually does say destination node schema. We invoke that. Edge direction says edge direction, edge table name. If that is edge table name, we might actually not need this edge table name. Why do we even have that? Or was it? We could at best just clone if need be, or to owned. Hey Moxo, how's it going? Hi, where are you chatting from? Thanks for joining the stream. I appreciate that. How are you doing today? And what got you interested in Rust? Welcome to the channel, welcome to the stream. Hope you're doing great. I appreciate you for joining. Maybe I should raise my voice a little bit so that you can hear me. But I want to be sure I'm not yelling when I'm also thinking out loud. Yeah, I hope you're doing great though. Destination node schema, then this foreign node connection method, and this edge to destination node method. Which name should we actually use? Edge to destination node method or foreign nodes? I think this is actually more descriptive because it's more specific. So I can say, yeah, I'm using, where else am I using it? Okay, edge to destination of method. Small better descriptive. Yep. Origins node struct ident. Origin. So I kind of created this, and if I want to do that, then maybe I'm gonna have to go. I'm gonna have to do origin node struct ident and into inner. Into inner. Okay, I mean, could just got something there. Yep. Or actually, we could just implement like a converter. Yep. Do something like that. So now we have this create assertion, the text relation, origin, struct ident. I think we might just be able to have this as a separate thing, or let's see how we're doing here. So we have the import. We have the import, but you were importing just the edge. Where are we using the imports? Okay. So edge type import. I'm just gonna call, rather than saying relations import, I'll say edge import. Actually, this is a single import. Let's import. Education model. Okay. So, actually, be nice to just get done with this destination active name. Why can't I just do active name? Yep. Then be checking. So I believe we actually so we had self being the node edge meta store thought this was what it was, but really, with knowledge metadata, but really we could, since now we're using that, it's actually gonna be node store dot node edge metadata entry. We'll check the edge table name. So basically, if it's not vacant yet, we insert that. Otherwise, if it's already been there, then I guess for that entry, I guess input that the occupied should be node add metadata store. Let's bring this down first. Where's this theme? Yeah, we've got that. I'll tell you what, we could bring it to employee. But I'm surprised this is given unknown, because I'm expecting it to be but it's okay. Now let me to data store. Why am I use let's implement into entry. What trait can we implement in that? We cannot do into iterator. Into iterator. But anyway, we don't have to complicate that. We can at best just do not that into so that gives this. So you're going to into that's rather than that. Oh, here should take into then entry. So it's already occupied. We're gonna take the item and we are gonna add to the destination node schema, and that takes in the destination node schema. We do that. Then we also add the node connection method. For node connection method, I think this should even be just called node connection method, right? Edge to destination node method. Honestly, I think it's better descriptive to say edge to destination node connection. Yeah, fine. Edge to destination node connection method. We can do the same. So we're just accumulating those destination node schema. So in this case, it would be destination node schema. Then this is edge to destination node connection method. So destination node table. Isn't this just destination whatever? I can actually just call this destination node connection. But yeah, but that's edge to destination node, whatever. We can leave that. We accumulate that, then we also accumulate the assertions and the imports. The edge import. We accumulate that, and but yeah, we accumulate that also. That's fine. Regarding the static assertion, we could, I think it doesn't have to belong to this. We can just put it at the top level, right? But it's okay. We decide to put it here, and let's say this first create static assertion. Now this takes not just an ident, but origin struct ident. Origin no struct idents. Origin no struct idents. You can come back. Oh, let's check this anyway. Let's check. Type foreign node table name. I think we can just say destination node table name. So here we are again the home node. Foreign node, I think we can call it origin, but let's leave it as that first. So depending on how we get home node idents. Where is that coming from? Home node idents. Are we actually using this elsewhere? Even not. Honestly, I think we're okay. We are. So we're checking that the type of the home node is the same as the origin struct. Depending on where you're coming from, depending on what is the origin, we're certain that home node idents. I actually love to check I'm using it currently. Node idents. That should be in. Let's see if I can search that. Okay. So why did I delete all this? Node idents. Why did I remove this in the first place? I see. So actually, yeah, since we're using the edge type, we couldn't actually just it's gonna be a little bit tricky now, because now you know what, why don't we just take this as if we take this as, let's say, node ident, node type, and we do this instead, so that it might make the output code a bit less readable, but it's more reliable in my opinion, because now we're gonna need the type here, the type, and here we have that. So I think this also wasn't working with generics and all that, but now that I might have to actually confirm that. Let's check this. Assert implement one. Let's check. So I'm using the static assertion here, and I'm not sure it allows you to use all those angle bracket and stuff. So that's the thing. Let's see if we got static assertion here. We can do use static. Maybe we don't. But what if I create some kind of, let's say, trait, and let's call this type, another type, and let's create struct fire. Implement mana for fire. What do I try to do? Static. Let's just fire as mana type. So if I do assert implement one, what if I try to take the entire thing and I do assert implement one and trait. Okay, it does work for this. So if it's not complaining, it should. Where we have generics, let's try to see what happens. We'll introduce let's introduce lifetime to make it more interesting, and let's do default. So you can do so what if we do something like huh. Yeah. Yep. So we do something like this for the implementation. That's gonna make for more interesting case. Yeah, so we might be able to just do that on node ident type, but for these we might have to do as the aliasing isn't gonna cut it. Yeah, so why would do something like that? We can add name checker. Why is this even? Yeah. Why is that here? We're not using that anyway. So where we go to something, no checker. So it's not actually used anyway, so we might as well just rip that off since we don't need it, and then we use this straight up. So we don't have to manually add it generics. So friend node ident net node table checker. Okay, let's say we're using the foreign node. Okay, we're checking the destination to table name, but we can do so. We probably assert fields. We could have these directly here. So checking the, I think that's probably what we want here also. So rather than having this, we can have this, but since we're dealing with the home node, okay, yes, since we're dealing with the home node, we can do this, but this would be origin, not table name. Let's just do origin, not table name. Not table name. I mean, technically we could take the struct and the struct type and do dot table name. That is one way we could get that, and that's actually turning a gear in my head, because if you really think about it, that's what we're trying to do, but from that we may not be able to easily get the direction of the relationship. So what we do could we can't naively do that, because this takes destination node, we're taking the foreign node ident, foreign node is the type, could be in a house. Yeah. We are foreign node associated type, and okay, make sure that whatever is the foreign node should I call that destination node? Wherever is the destination node, the foreign is what's on the other side. Yep, I think that should do all the checks we need. Node type. Probably should be the current struct name. Yep. But maybe we don't even need that, since it's not like, yeah, we can take that out first. But foreign node ident is something I probably want to take up here. So I just inline that and pass the token around. I'm going to now just go type. Yeah, this is pretty terrible, I think. H type, because check that implements edge, and field type is related node ident. Yep, it has to be relation of foreign node ident, but this is not exactly true, except we're gonna be taking out the generics. So how are we getting the foreign node ident? Okay, we're just using the name before, so it has to be a relation of, that would be the destination node, right? So that would be foreign node type, or what is it? So that's the edge, blah blah blah. As the foreign node type, right? It actually doesn't have to be. Yep. I mean, we can always come to clean this up. Can we? believing no, yeah. Can't call this static assertion. Static assertion token. No, yeah. So why are we then? Let's reference it. Why is that even a thing we are passing around here? Couldn't the good thing now is that we have the store here, so we could as well just store that directly, but we would have to do a bunch of cleanups here. So yeah, I don't think we should have the static assertion. I don't think it's necessary to have that. Yeah, since we already have something there, so we might as well just do like store dot static assertions dot push. We could actually just do this. Right, and this could even come earlier, or we could even pass in that as create static assertion. Like this could come after we have all the declarations. Yeah, okay, maybe that was alright. Then we do the madness. Generate static assertion. Are we using this? No. Oh, I see where we might be using this. So essentially, yeah, that also takes away the indirection, because yeah, we're going through all the hash map, the entries, then getting the static assertion from that, and this is just totally unnecessary now, because we are pushing that directly anyways. So we wouldn't need that. And rather than calling this generate token string, we could now just what we could do here is implement the tokens for but yeah, I mean yeah, we could then take everything here and do that. Token destination. I think that's yep. We are getting somewhere. Why do we have that there? Well, we could just call to string sim. Yeah. Couldn't we just call to string? Why are we even doing that? Okay, then we could just do this to string, right? To string. Okay. Oh, why couldn't I just... Isn't that the same thing? Oh, that's an ident. It doesn't really matter. Yeah, to do use type over and include generics, potential generics. Still work in progress, and relation is infinity. Okay, thanks to everyone for joining. I need to be out real quick. I need to go get some stuff done. I will continue when I'm back. I appreciate you for joining. It means a lot to me. And see you guys soon. Stay chilling.